Welcome to Plaid Day, right here at Aragon High School. Okay, so today we're going to graph these equations, these inverse functions that we did yesterday. And we're not just going to graph a plain inverse function, we'll actually do translations of them too. So the very basic inverse function is y equals 1 over x. You might call that the parent function. Although your parents aren't your basics, but anyway, that's what they call them, the parent functions. And the graph of y equals 1 over x and all of these inverse functions looks something like this. Have we done graphs like this already? Okay. Okay. So here are some particular things about these graphs. They they are split. They're split into two parts. Now, why do they get split? Well, there's a big old hole kind of in this graph. When x equals 0, y equals 1 divided by 0, and that's undefined. So I've got one point in here that's undefined, and so if I look at the lower left side, as my x's are getting closer and closer to 0, my graph is going straight down. And then when x is 0, I'm undefined, so now I get a discontinuity here. And then when I look at the upper right quadrant, quadrant 1, as my x's get closer and closer to 0, my graph goes way up in the air, way up to infinity. And so I can't connect negative infinity to positive infinity anyway. So I get this split in my graph. Now we have what are called asymptotes. And as this part of the graph in quadrant 3, the lower left, as the x's get more and more negative, the graph gets closer and closer to the x-axis, but it never touches it. Never goes over. Never touches that axis. Now, in the same quadrant, if you look at the right side of it, this graph will get closer and closer to the y-axis, but never go over it. So the same thing happens on the right side too. When x gets closer and closer to 0, the graph gets closer and closer to the y-axis, but never goes over it. When x gets bigger and bigger and bigger, the graph gets closer and closer to the x-axis and never goes over it. So those are asymptotes. When I have my curve get closer and closer to some line and hug and hug and hug it, but never actually touch it, then that line is an asymptote. So I have asymptotes. M, P, G, that did not. A, S, Y, M, P, T, O, T, E, S. I have asymptotes at the horizontal one is y equals 0. The vertical one is x equals 0. Okay? So now I'll try to graph some points on this. So let me make myself up a little XY table. And I'm going to graph the upper right first. So if x is 1, then y is 1 over 1, better known as 1. That is the point right here. From this point, it's kind of a little locator point. It's actually called a vertex. from this point, my graph will go down and hug the x-axis and go up and hug the y-axis. So let me just get 2 more points. One of them a little left of this little locator point. So maybe I'll go for x equals 2. And one a little bit to the, did I say left or right? Sorry. One a little bit to the right of this locator point at x equals 2. And one a little bit left of this locator point, but I don't want to hit the asymptote, so I don't want to go x equals 0, so I'll go x equals 1/2. So let me figure out the y's for those. 1 over 1/2 is 1 times the reciprocal of 1/2, which is 2, so that's 2. And 1 over 2, oh, that's just 1/2. Now I have the 3 points. So let me graph these other 2. Over 1/2 and up 2, and put a dot. Over 2 and up 1/2, and put a dot. And those dots will be enough for me to get the shape of this graph, of this function. Now I'm going to graph the lower half, and you may get to where you can just reflect and not have to actually make the table for these points, but we'll start off making the table. So for this one, I'll use essentially the same points, but we'll just go on the negative side of the axis. So I'll use negative 1/2, negative 1, and negative 2. 1 over negative 1/2, that's negative 2. 1 over negative 1, that's negative 1. And 1 over negative 2, that's negative 1/2. So I have the points over negative 1/2 and down negative 2. Left 1, down 1. Left 2, down 1/2. There are those 3 points that will help you graph that lower left side. You'll notice this little locator point it's always the same for the x and the y, because the locator point is on the y equals x line. So that kind of helps me get this little locator point. Okay. Now, when I get a little bit more complicated functions than y equals 1 over x, I go into my standard form. And that would be y equals a, won't just use 1, we'll use any number, over x minus h plus k, where h is the vertical asymptote in other words, the vertical asymptote is x equals h. K defines the horizontal asymptote, or y equals k. And A is a stretch or shrink factor. So we'll call it stretch. Sometimes it'll stretch it, sometimes it'll shrink it. Stretch it away from the 2 asymptotes, stretch it so it's closer to the 2 asymptotes at that vertex point, at that locator point. Or if it's negative, it'll reflect across ACROSS, the x-axis, if A is less than 0. Okay, so let's do a couple of simple ones and then we'll do one really hard. Reflect across reflect ACROSS. There we go. That's for A is less than 0. Alright, so let's graph y equals 9 over x.